Okay, good enough. Hmm. So, Krishna and Sai and Srinivas, and this particular model I would like to talk about, especially or include, machine learning concepts actually. Okay. So the first one is like we do have various modules. I would like to cover this particular series, and the first one is its introduction to machine learning. Introduction to machine learning. What exactly the machine learning, and the objective is that like we try to understand machine learning and why it is useful and what type of algorithms, and let's see some of real world applications as well. Okay, from the basic to advanced level. Clear that exactly this particular series of things. And as part of this particular series, then second module, what I can do. Okay, so in the second module, then I would like to talk about data pre-processing. So in data pre-processing, it could help you to process your data to understand by the machine learning. Okay, there we can try to understand handling the missing values and feature scaling, encoding the categorical variables, and we can try to split your data set into the training part as well as the testing parts. That's how we can able to train your model, and that's how the model we can able to evaluate it with help of testing data. That all things we can try to cover in a module number two. Okay, and coming to module number three, so then I would like to talk about linear regression. So linear regression means like we can try to build the models for our label data. It was in a continuous data that also we can try to understand in a linear regression concepts. And in module number four, I would like to talk about logistic regression. So this logistic regression, it could help you for to solve the classification kind of problems. Okay. And so as part of this particular series, like then I would like to talk about module number five, which is decision tree, which is a very, very important machine learning algorithm. I would like to deep dive into the decision tree, then how how we can able to split your data into the different branches and what basis we can split, and so what algorithms we can use inside of it, like a Gini or entropy or information gain. And while we are doing, we will get some kind of overfitting problems, then how we can able to, you know, solve it, that kind of issues also let's discuss in a decision tree modules. Okay. And as part of this particular machine learning, then I would like to talk about a random forest. Random forest. This is actually, it's a kind of ensembling method like bagging and boosting. Okay, so here I can clearly tell that, I cannot able to discuss about only random forest. Here I would like to talk about ensemble algorithms or methods. Okay, there we do have the boosting or backing kind of stuff is there that also we can talk about. And so next module or next algorithms, it could be KNN, K nearest neighbors. So this could help you for to classify the categories or classification models. We can solve it with help of KNN. And next one is this is 7. And next I would like to talk about support vector mission and Navy base, ninth module or ninth algorithms. I would like to talk about Navy base. Okay. And and 10th module, I would like to talk about, unsupervised machine learning algorithms. Unsuper, Unsupervised machine learning algorithms. So this all Navi base, support vector mission, KNN, random forest, decision tree, logistic regression, linear regression. These are all supervised machine learning algorithms. Okay. From the module number 3 to module number 9, these are all supervised machine learning algorithm. And at 10th module, we'll talk about unsupervised machine learning algorithm. Over there, I would like to talk about clusters kind of methods like k-means and hierarchical and principal component analysis, PCA, and DB scan, different kind of unsupervised machine learning algorithms. We'll discuss in a module number 10. Okay. And once if we know that, how we can able to build the models with help of supervised or unsupervised, then we need to be evaluated, right? Once if we build the model, that model, whether it is working fine or not, then we can use the model evaluation. Okay. Model evaluation. And meanwhile, we can model selection, how, at what basis we are going to be selecting this particular model or find, we are finalize your model, that also will discuss in a 11th module. Okay. So for model evaluation or selection, then we are using various concepts like cross validation, okay, or else bias variance trade-off, and greedy search and hyperparameter tuning. So these are all we'll discuss, hyperparameter tuning. These are concepts actually. Okay. And last but not least, let's see various end-to-end machine learning projects. Okay, like if I consider one particular use case, then how I would able to solve with help of this all methodologies like linear. If it is a regression kind of use case, then how could I use the regression, different regression models? How could I apply on this particular data, and how could I evaluated all these models, and how could I able to select the or finalize the model? That also will see one project from the regression, one project from the classification, one project from the clustering, unsupervised kind of thing, and the principal component analysis as well. Is it clear? So this is the this all the models will which is part of the machine learning only, which is part of the machine learning. So after you are after we done this all machine learning concepts, then I would like to be give you bonus kind of concepts, which is deep learning. If you would like to really transition your career towards into the artificial intelligence, once if you have knowledge in machine learning, which is not fair enough, but if you want to, if you want to see yourself as a data scientist, then this machine learning concepts, it could help you a lot, because you know Python, you know statistics, and if you know the machine learning concepts, then you can easily build the various machine learning model to to predict or to solve any kind of data science problems. But as part of the technology grows, like which there we do have artificial intelligence or generative AI or agentic AI. For that one, you must have knowledge on deep learning also. This is a bonus or optional kind of training. Okay, just 1 second, guys. So this is optional concepts, guys. Like if you're interested, to learn some more advanced concepts from our end, like I'm giving with a free of course, like deep learning, and with the deep learning, like artificial neural network, and first of all, how the deep learning architecture will works, and after that, how we could able to solve the all machine learning problems with help of deep learning. For that one, we could use the artificial neural network and convolutional neural network and recurrent neural network. Okay, these are all part of the deep learning. Okay, this is bonus concepts. If you know the deep learning, then whatever you can solve with help of machine learning, then simply we can do with help of deep learning also. But the main difference is that in two different scenarios we could apply it. For example, you have to solve the same problem. So we have some kind of problem, okay, business use case. I can say business use case. So this same business use case we can try to solve with help of machine learning. We can also solve with help of deep learning. So I can say if you solve the use case with help of deep learning, when you compare with the machine learning, so which is gives some bit more accuracy or good fit model actually. Okay, and in terms of accuracy, deep learning will high. Okay, it could be very high when compared to the machine learning. But thing is that in some scenarios only we can apply in a deep learning. In it depends upon the situation. If the situation is not sufficient for the deep learning, then definitely we should use the machine learning only. Okay, if you have all situations are good and everything is fine, then we can try to apply the deep learning. It's a depends upon the situation and the problem statement, and that kind of area we can either we can go ahead with the machine learning, either we can go ahead with the deep learning. So I can tell you in a simple thing actually. For example, you have one use case. For that one, if you want to solve that particular use case, make sure that you should have the data. Okay, this data, it is very very small. It is small enough. It is very small data we have it. That scenario we have to choose the machine learning. If you want to apply the deep learning to solve the same use case, make sure that your data should be large enough. Okay, we have the large enough. That situation only we can use the deep learning. I hope you I hope you understood at what a scenario we can implement the machine learning, at what scenario we can implement the deep learning. Clear?
Yeah, no.
Okay. So I would like to give you the concepts of the machine learning as well as deep learning also. And so if you want to understand the recurrent neural networks or a text-based thing, this is vision-based thing. Vision means image data or else video streaming data. So if you are working with the videos and images, then CNN it could help you. Okay, this is ANN, it artificial neural network. Whatever the machine learning problems we do have it, that all we can solve it like supervised, unsupervised, everything we can solve with help of artificial neural network. Whenever your data, which is like images or videos, that kind of problems if we have it, that kind of use cases if we have it, we can use the CNN, convolution neural network. Whenever you have some kind of text-based data, text-based concepts or text-based data, then we can use the recurrent neural network. If you really want to understand the recurrent neural network, then you must have the knowledge on the natural language processing. Clear? So I would like to talk about what exactly the natural language processing, tokenization, stemming, lemmatization, and embeddings. Okay, that all will talk about natural language processing. And meanwhile, after I completed deep learning, then what I can do, it's all bonus concepts, guys. As if you enroll for data science, then machine learning is fair enough. But if you want to learn more concepts, and I'm, it's open for you all. You just come for various classes whenever your time flexibility and all. We can try to learn. That's how it's important to get more information actually. Okay, and so once if we done the NLP, then I can talk about RAG kind of thing. Okay, so because wherever we go, RAG application or RAG architecture, which is very very pretty much important, because our GenAI, what it can do, there we are using LLMs, right? Okay, large language models. So once if you are understood the generative AI or large language models. And this particular models, why RAG will come to the picture, I can tell you. And see, here we have LLMs, right? So this LLMs, with help of LLMs, we can able to generate the new data or new context and whatever it is, that we can simply say that it's a generative AI. For example, you have a problem, and for that one, we are using one particular model, and this particular model which was trained on the some specific data, okay, or some period of time. For example, 2024 January only, we are till the 2024 January data only we are used to train you this particular LLM model. Okay, but now we are into 2025 June, right? Okay, so between this two also, there could be lot of data it already generated, and even current situation also the data is try to be generated, right? Okay, so this particular situation, our existing model, it is won't work for the current data, or or some after training the model, whatever the duration of the data, duration of the time we have it, that particular time, whatever data it was generated, so this particular model which won't work well. So for that one, what we are doing actually, we are implemented the RAG application on top of the LLM. So how it will works actually, so this is your model, and this is some external kind of data source, and that means this particular model, it was trained on some specific time only, right? Okay, so this is external database, and after training the model, the data it was storing into this particular data sources. Okay, for this model has to be accessed this particular external data, it could be too much time it will take, because the data it was an unstructured format, and it could be large enough, then your model, it will waste a lot of time for accessing the external data. So that particular scenario, what we do actually, we can use the RAG kind of thing. And so that's how, we can easily, with help of similarity such or cosine similarity such algorithms, we can use in RAG concepts. And that's how we can access this particular data. We can access this external data to this particular model with a very minimal time. That's how our model, it won't take too much of latency to solve or to give any new data, even current scenario also. That also, it's a RAG kind of thing. After that, in our industries, agentic AI is, it's a too fast growing thing now. Okay, so this agentic AI, how it will works, and whatever the problem or whatever the use cases we have to solve it, for that one we are creating various agents, agent 1 and agent 2 and agent 3. So these all different agents which was created and which is managed by the main agent. Okay, and this all complexity kind of thing, and even the internal agents also will talk to each other, and that's how agentic AI will work actually. Okay, so this all autonomous, we don't need to implement manually anything. Automatically this all internal agents will talk each other, and it can be solved without interventions of any kind of human. And we are reducing 95%, 96 to 98% of human interventions, we're reducing with help of agentic AI. And so that's how, any kind of applications we can able to solve it with help of agentic AI. And to understand this agentic AI, we need to understanding the generative AI and RAG kind of thing. And if you want to really understand this Gen AI or RAG and RAG kind of thing, and deep learning and machine learning are the fundamentals for that. Okay, so this is my plan of action in upcoming sessions in a series wise actually. Okay, clear?
Yeah,
Yeah,
clear,
clear, sir. Clear.
So, if you feel that if you're not comfortable with machine learning, don't worry. I can explain you from the scratch again about machine learning. Okay, it's not a big issue. It's a very small enough concepts. We don't need to uh, put too much efforts actually. Okay, so where we need to put too much effort, because wherever the current technology is there, there we can try to put some more efforts actually. So this machine learning concepts, if you aware of it, yes, you at least if you see that decision tree, okay, decision tree, it's a machine learning algorithm, it could help you for to solve the classification and regression. If you have that kind of idea, is fair enough, to work with this newly advanced kind of concepts actually. Okay, because even with help of these things in a backend, or we are going to solve This kind of problems only, this with help of these problems only we can solve it actually. Okay. So anyway, I would like to talk about module number 1, which is introduction to machine learning. Any questions so far?
No, Anjan. Good.
See, I would like to say anything before we do and make sure that we are working on the data. Data means it's not small enough data, it's a data set. Okay. Data sets are different formats. Data sets are different formats. Some are CSV file formats, comma separated values, or else Excel, XML formats, or JSON data available. Okay. Or else it might be a PDF data, you might have it, or else a text data or a txt dot text format it will have it. So data set means some collection of data in any one of the specific format, or else even you can combine this all data, we can call it as the set also. Okay. So data set means it's some historical data in any problem, any scenario, any domain. Okay. So data set means it's some kind of historical data and which is replicating the real world data actually. Okay. Clear? So
Yeah,
first
clear.
thing is that we need to understand what is machine learning. As part of module 1, like introduction to machine learning, my first question is what is machine learning? Srinivas, can you? Hmm? Srinivas, Sai Sankir, and Krishna, do you have any kind of idea what exactly the machine learning? What is machine learning?
Not properly.
Okay. I can tell you in a simple format actually. Okay. So machine learning, what it will do, it's very simple. And let's consider this is your computer, whatever it is. Okay. And here we have some data set. And so what we are doing actually, and we are making the computer, we are making this particular computer, it could be learns itself. It could be learns itself. And we are, we are making the computers learns from data. Okay, this is the computer or it's a mission. This computer or mission, it could be learns from this particular data. After that one, and we can make the decisions always as well without any explicitly program or explicitly coding and all. Okay, without using much code. Okay, what we are doing actually, whatever the data we have it from this particular data, our computer, it could be learns itself, and then with help of that one we can make the some kind of decisions without any explicitly program. Is it clear? In a simple word, what we are doing actually, it's a field of study. It will gives the computers to ability learn without any being explicitly program in a simple format. And I can tell you in a simple and process actually. For example, you have some data. You have some data. So this is the data. If you provided to any machine learning algorithms, any machine learning algorithms, it could able to train with this particular data set. And once training is done, which is generated the model. Model means just a piece of code. Okay. And this particular model we could use for any unknown data. If I'm giving any unknown data, it could able to predict or it could able to identify the output and outcome of this particular unknown data. Okay. See, here, have you used any explicit program over here? Okay. Have you used any explicit program? And for more understanding, I can tell you a traditional programmer and you are the Python developer. Just imagine you are the Python developer. Okay. So I'm giving some use case. The use case is um, calculate the calculate the addition of addition of two numbers. In generally, what we do as a Python developer, so we can start immediately writing the addition program, right? And so we are taking that input and we are taking the b as input, and then we are calculating the a plus b, and you are able to some return or print the c value. This is how we are able to write the logic, right? Okay, and that means you are able to write the code for this particular problem. To solve this particular problem, we are implemented the code. But actually the machine learning engineer, what he do, he have some kind of historical data. Okay, so this is a and this is b and this is c, and 5 plus 10, and it's a 15, and 10, 6 plus and 6, and this is 12, and it was for example, how much it is, it's 18, and this is 3, and this is 20, it's a 23, something like this. This is my data set. Okay, if I have this particular data set, this is the data set I'm giving as input for my machine learning algorithm. Once I able to give the machine learning algorithm, and based upon this particular data, and meanwhile, before I'm training this particular data set to my machine learning algorithm, I can give that, this is the output and these two are the input. This kind of information I can inform to my machine learning algorithm. That particular situation, this particular machine learning algorithm, it could identify the pattern between your output variable and input variable. And once it is identify the pattern or the logic behind this particular data, it could able to it could able to build the model. This particular model, it could help you addition model. Okay, if I'm giving any new inputs, for example, if I'm giving the 20 and if I'm giving the 30, then automatically the model, it could able to give you output is 50 actually. Clear? Is it clear or no?
Yeah, clear, clear.
So machine learning algorithm, it's just a base idea is it's very simple. Without any explicit program, how the how the without any explicit program, and we need to give the data to your computer machine, it could learn itself. It could learn itself, and then from that particular study or from that particular learning process, it could identify the patterns, and it could able to build the a model, and that model we can use for any new inputs, unknown data. So now this one and this one is doing the same task. Okay. But thing is that this one you should implement yourself, and you should have the logic how we have to do it, and you should have the logic. Okay. And if you know the logic, then only we can able to build the code. But coming to the machine learning algorithm, you don't worry about logic and all. Okay, automatically the machine learning algorithm, it could identify the logic from this particular data. Clear? And the logic only which is created as a model, that model we can save. And so once if you save the model, and we can use for wherever you want to use it. You don't need to train multiple times again and again. Once if you train you and you build the model and you just save it, and wherever you want to use this model, you can use it without any training for new data and all. Clear? Now you understood what
Yeah.
exactly the machine learning.
Yes, Sanjay.
Okay. So now when we are working with machine learning, we can handle complex kind of data, and we can take the automation decisions as well. And it could help you to accurate predictions. With help of this particular machine learning algorithms, we can train, and from that one, we can get the accurate predictions or accurate results actually. Okay. So we can able to use this kind of concepts in various domains, and we can use for healthcare domain. I can give you small example. Okay, you newly started one hospital. You newly started one hospital. Okay, and hospital is too big only. Hospital is too big, but within that one, you should maintain the infrastructure also, right? Okay, you should maintain infrastructure or not. But see, you are newly started hospital, and you don't know how many patients will visit to your hospital. Am I right or not? That particular scenario, if you maintain the infrastructure in a from the day one onwards, it might be lost for you, right? Okay, so that's the reason what we can do. We can able to build the machine learning model, and so this model, if you given historical data, it could easily identify the today how many patients will able to arrive to your hospital. Okay, that is the one use case. Or else, next one is, for example, you have some kind of patient details. Okay, and so he has done some lot of scanning and all that kind of data, patient reports, scanning reports, on all details are available. So this particular patient details, and if we have any machine learning models, and so it could easily identify in future what could be the diseases he might be face. So before he is able to, he is attacking by those particular new, diseases, before that only he can able to take care about taking care about his health. That's how he can maintain his health and also. Okay, that's the one different one use case. Or else finance. In case of finance or banking, like you want to approve the loan, all you want to approve the loan, you are the bank employer. Okay, you want to approve the loan, and it's very tough to data what we have it to finalize this particular person will get the loan or not, right? Okay, for that one you have some kind of historical data of various customers, and from that particular customers, it someone has approved, someone was rejected in different perspectives. With help of this all data, our model, it could able to build for loan approval model and all. And if you give any new data, automatically that model, it could give you the result, red flag or green flag. Okay, clear? Like that, wherever we go, we can go with the hospitality domain, or else e-commerce domain, or finance domain, or banking domain, or manufacturing domain, or any kind of semiconductor domain. You can just go for any domains. The machine learning we could use for wherever the data is there in this particular domain, and with help of that data, we can do some kind of future predictions. Okay, clear? The use case, it could be anything that we can simply solve it with the help of machine learning. Any question? Hello.
No, Anjan. Yeah.
I would like to talk about different kind of machine learning algorithms. Okay, I think you already aware of it. And the first one is supervised machine learning algorithm. Second one is unsupervised machine learning algorithm. Third one is reinforcement. Okay, reinforcement. And see, simply here, supervised machine learning algorithm and unsupervised machine learning algorithm and reinforcement, which are three types of machine learning. And coming to the supervised machine learning algorithm, what it will do, okay? So you have some data set. So this data set, it's clearly identifying what is output and what are output based upon your problem statement. Okay, you have input and output labels. So that scenario, we can simply go and apply the supervised machine learning algorithm. Okay, and you have some data, and you don't have any kind of output label. You have just data, we have it. So this is your data actually. There is no output variable. So this kind of scenario, we can just go and apply the unsupervised. Okay, so coming to the supervised machine learning algorithms, we can solve the regression problems and classification algorithms. Regression means this output variable, if it is the number data, this output variable is the number data, we can choose the regression based algorithms. If in case this output data type, it is the categorical type, like classification type, then that scenario, we can go ahead with the classification. Okay, and you don't worry about output variable, because there is no output variable. You have some set of data. From that particular data, we have to be do some kind of clusters, groups. Clusters means groups, or dimensionality reductions. Like from this all features, we can identify some of the features are fair enough, so we can reduce the data set with help of dimensionality reduction. Okay, and coming to the reinforcement, there is no data actually. It is learning through rewards and penalties. Okay, so you are created one mission. I can say reinforcement actually, and for example you have some kind of machinery. Okay, and this mission, it could sometime it is working fine and sometime it is not working fine, right? At what scenario which is not working fine, and that data we can collect, and that is learning process. Okay, if your machine is working this condition which is getting some kind of positive rewards, and as this condition the machine is not working, then it could be the negative rewards. That's how the reinforcement it is working based on the rewards and penalties. Okay, so in simply reinforcement machine learning algorithm, there is no data. There is no data, and even though we don't have the data, based upon the rewards and penalties, and you're able to identify the model, and you're able to build the model more effectively also. Okay, like the example is for the reinforcement machine learning algorithm, the best example is self-driving car. Do you have any kind of self-driving car before ever? No, right? Google was working on self-driving car, and see, even a lot of it is already comes into the real world also, right? Okay, without any driver, the car it could able to travel from one location to another location if you just simply give it your destination. Okay, how it will actually? So it's environment, right? From the environment, which is learning actually. Okay, so with what direction we should go, and if it is the wrong direction, then you should get some kind of penalties and all. Okay, clear? And penalties not in terms of money and all, just in terms of model improvement, feedback kind of thing. Okay, so I can definitely talk reinforcement whenever I started generative AI. So this fair enough, like supervised and unsupervised. Any questions? Hmm? Any questions? Let's see some of the real world applications, like what kind of applications we can do with help of machine learning. One is fraud detections. Before we did some kind of transaction. That particular transaction is a fraud or not. Before transferring to the um, um, uh, payer, or it automatically identify whether it is a fraud transaction or not. Okay. Second one is product recommendation. Product recommendation. Okay, so whether, for example, if you are working, you just open the Netflix, right? And whenever you open the Netflix, you will get some kind of lot of movie recommendations, right? How it will actually. So you might already viewed some of the movies, or previously based upon that particular genre, and based upon that kind of features, it could recommend you some new movies uh, for you actually. Okay, and meanwhile, stock market predictions or stock market forecasting, that also we can do, and medical diagnostics, medical field, and voice assistant like Alexa and Siri. There's all kind of applications we can do with help of machine learning only. And see, I would like to talk about machine learning workflow. If you understood this one, like how the machine learning will start and all, we'll try to understanding the ML workflow. Okay, we can choose any algorithm, or we can choose any application or use case. This is the workflow we have to follow it. Okay, this is the crisp model actually. First, it's our problem definition. Okay, so problem definition or use case. So the problem definition is, I do have predict whether the transaction is fraud or not. That is my problem statement. And if you want to solve this particular problem, you do have data, right? For that one, we need to do the data collection. For this particular data collection, we have to use various methodologies like web scraping, or else the company already provided, the bank it might be provided, and from the different sources we need to collect the data. Okay, once if we collect the data, then the next step is we need to process your data pre-processing, because the data it was in a raw format. So that particular raw data, then what we are doing actually, we are making into the model understandable or machine learning understandable data. Once data is pre-processed, then we can model selection. So which model, whether it could be supports the um, it could be supports the regression based model, or it could be selected the classification model. We have to be select the model actually. Okay, algorithm selection. Once a model you selected, then we would like to train your data. See, you collected and you pre-process it, right? And with help of this particular pre-processed data, we can train your data. Once if you train the model, then next stage, we need to go with model evaluation. Model evaluation. Once model is evaluated and it is working fine, then we can go with predictions or deployment. We can deploy your model wherever you want to be use it. Okay. And if in case your model was evaluation, which say that your model is not good enough, then either we have to either it might be because of data insufficiency, or else data you are not pre-processed well, or else a model was not selected well. So that is the reason in any one of the stage it might be the problem. So it's keep on working on it actually. Clear? Is it clear or not?
It's
Yes,
clear.
clear.
Yeah. So now what we can do, this is the workflow of the machine learning model. Last but not least, which is the if you want to solve this kind of thing, then what we required. You might be thinking like, I do have solid knowledge in coding. No, you don't need any too much coding skill. Just understanding Python script is fair enough. So, and we do use various libraries, NumPy library, Pandas libraries. Have you seen these libraries? I think I'm explain or not while I'm explaining the statistical concepts, NumPy, Pandas, Matplotlib for visualization kind of thing. I showed you
Yes,
some examples, right?
Yeah, yeah.
So
yes,
Yes.
yes, we are
NumPy,
aware of
Pandas,
this.
yeah, NumPy, Pandas, Matplotlib, and Python. So this NumPy, Pandas, Matplotlib, it could help you for this pre-processing data, model selections and training. Sorry, pre-processing. So till this area, this models it could help you for model training and for model evaluation. Then we do have another model is scikit-learn. Okay, and mm, and if you're using the deep learning PyTorch and Keras, we could use it. Okay. Yeah, I hope you understood, right? In terms of coding or in terms of libraries, what we could use it to solve this kind of ML algorithms, or any problem statement, how we can able to solve it. And this is our workflow only we do follow actually. Okay, first you do have the data. Without data, we cannot go for the next step. And you have the data, and it is not in a proper format to understand by the machines. Machine learning, it could understand only numerical stuff, not any categorical missing data or data not in a proper format. So it is all our problems as a data pre-processing engineer or else machine learning engineer. It's all is our problems. We have to spend most of the time for pre-processing your data only. Okay. See, this model training and model evaluation is just you know mm, two-step process, and within fraction of seconds we can do. Okay, but this pre-processing, which is heart of your entire ML workflow, if you not work properly on data pre-processing or EDA exploratory data analysis, that scenario, your model it won't work well. So that's the reason, and 80% of the work or 80% of the time, 80% of the time we are spending for the data pre-processing. That is the main drawback. But in case of deep learning, you don't worry about data pre-processing. You have a data, and we can directly start training your model, and we can evaluate it, and that's how we can do it actually. So you're not wasting too much time for data pre-processing in deep learning. That is one of the difference between the deep learning and machine learning. Clear?
Yeah,
Yes,
clear.
yes, clear.
So guys, whatever we see in previous sessions, that is our fundamental things for what we are learning from the next things actually. So and so I'm going with this flow again. And if you're not understand any small thing, please raise your voice in a class itself and let me know. I can try to be explained it that time itself. You don't need to waste too much time for that. until for the next sessions, or else until anything. You just ping me anytime. I can try to be answer your questions in a offline also. Okay.
Sure.
Yeah, Anjan, a small doubt actually. Yeah, after model evaluation in the ML workflow, we are doing the predictions. Predictions are some deployment on the unseen data only, right?
Yes, yes. Right. Deployment means what? We are deploying into any one of the cloud or server, and that model we can use it for any new predictions, or for new any unseen data. Okay.
Yeah, okay.
Okay. Yep. That's for today's session. I hope you enjoyed this particular class, and let's continue for the tomorrow's. I mean, Monday. We'll meet on Monday. Okay.
Yeah.
Thank you,
Okay.
guys.
Thank you.
Okay. Thank you.